Hey guys, so in this video we're going to be talking about module scripts, which are, go here, oh, module scripts, because normally, right, or not server scripts, you have regular scripts, you have local scripts. I mean, I've just typed script, you can see them all. You have regular scripts, you have local scripts, and you have module scripts, right? Well, regular scripts and local scripts are usually pretty well known, but not a lot of people know how to use module scripts, right, or what they really even do, right? So let's create a module script. Let's put it in replicated storage, and I'll explain why later. And then let's demonstrate how this works. So let's create a new local script, right? I'm gonna do local replicated storage equals game get service replicated storage, not that replicated storage. This is just for testing. And if you look, so like when we created this script, we actually already have some code in here, right? And what it does is it creates a table and it returns the table. Now we can just get rid of that, but I'll explain the basic how this works, you know. So in order to use a module script, right, it's kind of like a function. Think of it like a function, right? So if we do like print test, right, print other test, return false, right? I'm gonna do local return, or local what it returned equals require rs dot module script print what it returned. And when we play the game, it'll run the local script, and we can see it prints all those things, right? So what's going on here, right? So we require the module script, and basically requiring it, if this is like a function, then requiring it is like calling the function, right? But I believe if we were to do local what it returned to rs dot module script, if we were to do that, we would require it again what it returned to, then it prints the same thing, but it doesn't print these ones, right? So that's a key thing you got to keep in mind too. But so basically, when we require it the first time, right, it will run the script, and so it'll run these things, and then it'll return, and it'll get whatever it returns, right? But then when we require it the second time, it just gets this. It doesn't run all this because it already ran it for this script. But here's another thing we want to look at, right? So it works like a function in that manner. I don't believe you can have multiple values. I don't think you can do something like this. So if we were to do like return 1, return 2. So it's not entirely like a function. Yeah, because you can only return one value. But we're gonna go over why that is later. But for now, let's have a look at like what happens when we do this in a server script. Because this is from a local script, right? We're requiring it from a local script. But you can require a module script from either the server or the local, right? So server script rs local module equals require, or local return 1 equals require rs.module script, right? So now if we do this, we're going to get rid of this. We're going to do local run service. We're going to do run service is client, or print run service is client, print run service is server. And you'll notice, so both of these are going to be requiring it, right? And they both have the exact same code. Right, they do the same exact thing, and they're both going to be requiring it. So what we see is we get an error. Oh, let me fix that. Okay, that's a lot of things. Let's move this around so it's a little easier to tell what's happening. Put a little line there. Okay. Let me also oh. Just so we can tell what's happening. Okay, so it's still a lot to look at, but so look at the green and look at the blue, right? So the green, this is going to be the server, right? I believe. Yes. Yeah, because is client is equal to false, is server equals true. So this is being required from the server. So this is actually running the module script on the server, right? Then, of course, it gets the return, which is false. And then we run it on the client too, and it actually will run it again because it's from a different script, right? So it will require this again, but this time is client is true and is server is false because now we're running it from the client. So basically a module script, it runs either server or client depending on whatever you require it from, right? But maybe the better way to think of it isn't that it runs on whatever you require it with, but rather that this is like it's like a package you download to the given script, right? That's why when you do require a second time, that's why if you require it a second time, right, then it will it already has the return, right? It already has the return, so it doesn't need to run it all again. But so that's the basic usage of them. But so what's useful about this, right? How does this help with anything? You can only return one value. It's like a function. But what if you need to return multiple values? Well, that's pretty simple. You could return a table because that's technically one value. Right. I'm going to get rid of the local script because the server script will be easier to test. Okay, so we're going to require it. Then we're going to print module, right? And we're going to ignore this. And we can see it prints the table, right? So we're going to return a whole table through that, right? And so what's useful about that? Well, that gets into something known as, well, I mean, you could do a lot of things with that. So probably one of the most common things people do with that is they create a table or something, right? So we do creating module, as we'll call it. Local module equals a table. And then function module dot this function. Now this might be some unfamiliar syntax to you, but think about it like this. So this is basically, so if we were to do this and we were to return module, right? So that's what you would normally do, right? And you can make another function module dot this other function. You can do the same thing, right? And then when you require it, so we're going to do print 1, print 2. So if we were to require this, so let's print it 2. Module dot this function, module dot this other function, right? We can actually run those functions from that module. So let's try that out. Yeah, so it actually runs those functions and it can print those things, right? And we can also look at this. Oh. Yeah, and you can actually see it has the functions inside the table. But that's basically what this whole syntax does, right? So imagine this is essentially another way you could do this is you could do it like directly inside the table, right? So you could do like function this func, maybe. I don't usually do it like this. So wait. You could do like this func equals function, like that. So that's one way you could do it. And you could put the function in there. You could do this other func equals function. You could do it like that too. And then essentially when you do it like function module dot this function, right? You do it like that. It's essentially like doing module dot this value equals true, right? in a string, because why not? Hello, right? So that's essentially the same thing as doing that, but we're defining that as like a function, right? You could also do like function module or module dot this function equals function. That's another way you could do it, right? And that looks kind of the same as like module dot hello world equals hello world, right? And that's kind of the same sort of syntax there, right? And of course we can also specify parameters. It's not a 3. Okay, yeah, we can also specify parameters. We can do like, we can actually see the parameters in here too, which is kind of cool. So we can do like true, false, hello 5, right? We do print ASDF param 2, right? Okay, get rid of this. And so that's kind of cool, right? And that's just because of how tables work, right? This is all just tables. So you don't need a module script to do this. This is just tables. You can do this all in a local, or in a local script, in the server script. But what makes a module script useful is the fact that you can actually create like a template and actually like sort of duplicate that template in a way. And I'll get more into that when I discuss object-oriented programming, which is essentially what I usually use module scripts for. I mean, there's a lot of things you could use them for. It's kind of a wide variety of use scenarios, just depending on what you're doing. But anyway, okay, so before we keep exploring module scripts, let's explore what exactly is object-oriented programming, right? Or OOP for short, right? OOP. So what exactly is that, right? What does that mean? Well, so let's look at it like this, right? So we can do local part equals instance.new, right? We can do part workspace, right? We can do that, right? So what is that doing? That creates a new part, right? A part is like an object, right? And the object has properties like part.canCollide equals false, right? We can do part.anchored equals true. We can do, then there's also functions, right? We can do part dot wait for child, part get children, part get descendants. We can do all of these, right? And so it has properties, it has functions, it has all sorts of things, right? And we can do things with this part. But then we can also do part clone, right? We can create a clone of that. And this is essentially what object-oriented programming is. We have an object based on a template, which is the part, right? It's just a basic part. And it has these properties based on that part template, right? And so, we can do any sort of instance, right? We can do bool value, right? It'll be the same. It's still an object. But what if we were to do local params equals raycast params, right? That's the same sort of thing, right? This creates a new raycast params object, and we can do params.filter type equals enum.filter raycast filter type dot blacklist or something, right? And then do params dot filter descendants instances equals a table, right? This is an object we're creating, right? A params or raycast params object, and then we change the filter type property, and we can change the filter descendants instances property. I don't know if there's any functions we can do. Yeah, I don't think there is. It's because it's more like a information storing object. But that's the general concept of what an object is in object-oriented programming. So object-oriented programming is programming oriented around objects, right? So that's simpler enough, right? But how do we actually create our own objects? That's essentially what we're doing here with module scripts. So that's how I use them anyway. And so just to give an example of what you can do with a module script, right? I'm going to do something I've done in pretty much all of my games at this point. I'm going to create a player stats module. And basically, I'll explain what that is. Right? So we name it player stats. We're going to do module local player stats equals a table, right? Then we're going to do return player stats, right? And then we're going to do instantiating. It's a big word. Function stats.new. And this is going to be like that raycast params.new, right? It's going to be that same sort of thing. And so then we're also going to do player, right? We want to specify the player for that specific player stats. And so here's the cool thing, right? So this is where we're going to get into metatables. And metatables are kind of, they're a whole thing. If you want to look into them, you can. I don't know if I want to really go over them in this video, but I can link some resources if you need to figure out what those are. But essentially what we can do using metatables is we can do local self, just as a variable name. It turns red, but that doesn't have any significance. In this case, anyway, it doesn't. So you could do like local player stats, right? You could do that if you wanted to. I just do self because it's consistent with what comes later, right? So local self equals set meta table. We're going to do an empty table, and we're going to do index equals player stats. And so what does this do, right? So first, you're probably going to want to understand the basics of a metatable, right? So we create a table. This is an empty table, and we're going to put this metatable on the table, right? And so this metatable has the index meta method, which basically if you ever index this table right here, if you ever index this table, which is going to be self now, then if it doesn't have anything in this specific table, it'll go to player stats instead and see what's in here. So if we had player stats dot this value equals haha, right? We can do right here, we can do return self. And so then if we were to do this, we can do local rs equals game get service replicated storage local player stats equals require rs dot player stats, right? We do local ps for player stats equals player stats dot new. We're gonna do what we're gonna do actually. I'm gonna speed through this. Okay, so I've typed it all out now, right? So basically we want to create a new player stats for every player that joins the game, and we want to just test around with it for now, right? So we added this value here inside the table that's actually being returned, right? And then if we do this table dot new, we're gonna get a self with a metatable with index set to this table. So whenever we index a value that's not in this table, it's gonna go and check this table, right? So theoretically that's how that's gonna work. And then it's gonna return that whenever we run this function. So here we get the services, we get the module, we require it. We create a new variable which we're going to use later, and we do player added. So this is just getting all the players. This is just my own little way of doing player added that's a little bit more efficient in case there's like a player that's already in the game before this script runs or something, right? Most likely not going to happen, but if this is like we have all this stuff up here and this is all the way down or something, and there's a whole bunch of stuff that happens before this, then it might happen, right? There is a chance that something could go wrong. Anyway, so we have this. We're going to print the player stats, and we can also do print player stats up this value, right? We can already see that value is in there, because this is going to be the self that we created, right? And I'll explain why I call it self later too. But this is going to be the self, and it has the metatable set to this. And so when we try to index dot this value, we can already see inside the metatable that value exists in the metatable, right? And so if we were to run this, actually no, we actually need to join because it's on player added. So let's join. See, it prints an empty table, but it still knows what this value is, right? So even though this table is completely empty, right, it still knows what this value is, and it can still print that value. And so the main thing that I use that for is actually for the functions themselves. And so what we can do now, right, we can do, so first, I'll get into that later actually. So first what we're going to do, we're going to include the player because that's going to be an argument here, right? And then what else we need to do is all stats player equals PS. And this is so we can store them for later usage, because these are essentially tables, and so all those stats are going to be done inside of tables inside of one script. And so all the stats are going to be going through the script. If you want to write the stats, you need to use a bindable event or a remote event. Or if you want to get the stats, you need to use the remote functions and bindable functions, right? And so everything is going to be going through the script, but we also need to store all the stats for every player that joins the game, right? So that's what this is going to be doing, right? But what else we're going to do is, so this is going to be creating self, which I'll explain that later. And we're going to do self.stats, or self. Let's say, so say we have like an agility stat, right? Agility equals 1. Self.strength equals 1, right? And then self.endurance equals 1. So we have these three stats, right? And now if we were to print this, so these three stats are just values inside of this table, right? We're just putting those values inside this table, which has the metatable attached. So whenever we run this, it'll print the table, and we can actually see these are our stats, essentially, right? And another thing we're going to do self.player equals to players. So that way, if we ever have the stats, we can also figure out what player these stats are for, right? And so we have that. Those are the stats. And then, okay, so, well, how do we do things with them? Well, obviously we can do ps.strength plus equals 1 or something, right? And so that's pretty cool. But what if we wanted a function to, like, level up all stats or something, right? So we do leveling up all stats. Function player stats level up all. Then we're going to do amount. And so, well, what's different here, right? So this is another function, right? And it's inside of this. It's not inside of self. It's inside of the player stats. And so why is it inside the player stats? Well, that's because we're using this colon here. So this colon, so this is actually where self comes in, right? So this colon is actually going to, I don't really know how it all works, how it ties in with the metatables and stuff, but basically if we were to do self here, if we were to do print self, then this self is actually going to be equivalent to the specific player stats that has this function being ran on it, right? And so by having this colon here, it actually essentially defines self for us as the table that's being ran, right? So we're to do ps dot level up all, right? If we were to do that, and if we were to play, it prints nil. Print self was nil. Why isn't it? What? Oh, it's because so since this is a colon, then we actually need to call this with a colon as well. Either that or okay, so we can call this with a colon, right? If we hit play, it should print the player stats. Yeah, it prints the player stats, right? And we can actually see it actually has the player too. And that's because print self in this case is the actual specific player stats, right? But what we can also do is use a dot, and then we can put ps as the first parameter, then whatever amount, right? So the other parameters would just So the other parameters would just come afterwards. So ps that level up all, and so that works the same as using a colon. And so the use of that is you can do like you can essentially do what I did here, right? Because normally you'd do like you can do it in task.spawn. You can do ps or ps.level up all, because that's essentially like a property, and you can do ps and amount, and then that way you can do it in task.spawn if you wanted to, but that's not really important. So so what we want to do with this function, right, is we want to level up all the stats, right? So we're gonna do print ps, right? I'm going to do print ps again. And so what we're going to do here is leveling up, right? So local stats, this is going to be a table with some stats in it. Agility, strength, endurance, right? For I stat in pairs stats list. And we're going to do self stat plus equals amount. Alright, so that's going to add this amount to every one of these stats, right? And so level ball by 5, right? So it's going to print at 1 and it's going to print it again. You can see the stats all go up by 5, right? So now they're all 6. And so while that specific example isn't really too useful, but what makes this player stats object, because this is essentially an object that we've created, right? That's kind of how this all works together. But what makes this really useful for in like the context of player stats is you can make a save and a load function, right? So you can do services you can get data store service. Oh. And I'm going to do data store local stats or stats stats data store. Okay, equals data store service get data store, and we're going to do stats data store, right? Okay, so we created a data store named stats data store, and then what we can do is we can create saving, right? Function player stats save, and we don't need to specify anything because we already have the self from this colon here, and that's kind of the whole benefit of using this sort of format of doing it. I don't really know how to do this colon thing with other formats. It might be more complicated, but so then we can do creating. Okay, so this is something kind of cool that I like to do. Local hs equals game get service http service, and so this is the only thing I've ever used http service for, if I'm going to be completely honest. So we're going to do creating string, right? Or creating save table, and so local save table equals agility equals self.agility strength equals self.strength endurance equals self.endurance, right? And we're going to do local save table string equals hs json encode save table, and we can do saving or stats or bs set async self.player. So that's where setting that player property comes in. User ID save table string. And so now what's cool about this is so essentially what we've done here, right? So we created the save table, which has our stats, the stats that we want to save, because we don't want to save the .player, because that's going to be an actual object, and there's not really a way we can turn that into a string, which is what comes later, right? So then we create the save table string using our HTTP service JSON encode on the save table, and basically what JSON encode does, essentially you can encode a table into a string that is essentially just better for storage, right? So this is going to use a lot less storage than saving the table itself. I mean, you could save the table itself, but if you have like tables inside this table, right, then it's gonna take up a lot more space a lot faster. But this JSON encode is going to essentially alleviate that issue. And so then we're going to get the player user ID and save the table, right? So that's going to save it. Okay, so now we can save it, but we need to actually load it in order to test that. So we can do another function for loading. Function player stats load. And then we're going to do getting string table local table equals stats ds get async or self dot player dot user ID, and so we're going to do if string if string table, then so if there's a string table saved, getting table, and we're going to do local loaded stats equals I don't know what that is. HS JSON decode So now we're going to decode it. String table, and then we're going to do loading stats for stat name, comma, stat value in pairs. Loaded stats. So now this is a table, right? We've essentially turned the string back into a table. And then we're going to do this, and we're going to do self stat name equals stat value. And so that should automatically load all the stats. And so now we're actually going to put the load function in here automatically, loading stats, because we want the stats to be loaded essentially as they're created. So we're going to do self load stats, right, or load. So now theoretically, so this is going to level up each stat. Actually, I'm gonna add that function back because we removed that. Let me add that function. Bring up all stats, right? Function player stats. Level up all amount. Or 2 level equals agility, strength, endurance. For I, stat name in pairs, 2 level, do self stat name plus equals amount. Okay, cool. So that's gonna level them all up. So that should work now. Oh wait, yeah, I need a API services. Let me change that real quick. Oh, okay, cool. API. Cool. So now we can see it prints the stats. So we have the before, we have the after, and it adds 5 to all the stats. And then what we're going to do, we can leave. We don't have any print messages for when it saves, so I might add some of those. But theoretically, if it works, maybe it doesn't. It doesn't work. Okay. So let's see. So it already runs the load function. Okay, wait, so print saving print string.format saving the stats of player self.player.name. Print done. Okay, I'm going to ignore the random voice cracks. I'm not going to worry about those. Saving, we're going to do loading the stats. So to do those, print. So we're loading the stats, and if we leave, it doesn't save this. Oh, of course, I need to actually save the stats. Let me just do that manually for now. Save. So if we save the stats after we leave the game, or not after we leave the game, but after we up the stats, saving the stats of player, done. Okay, so it saves. Then if we run again, it should load the stats. And now we can see our stats have loaded in with the upped values, and they go up even more. So now we already have a stat save system, right? It's as simple as that. And it just keeps going up, right? And so that's all we need to do for a stat save system. That's the whole stat save system. And then what's even cooler is that now we can do saving stats. We can do like player stats dot autosave or delay equals every maybe 60 seconds. Right? For testing, let's do 15 seconds, right? Saving there, let's do autosave or task.spawn function while self.player.parent do, and we're gonna do task.wait self.autosave autosave delay. That's going to be coming from up here, but that's going to automatically go into self as well. And so then we're going to do self save. Cool. So that's going to be an autosave. And we can test that. We can see that it should automatically save every 15 seconds. So it saves because of the server script. And if we walk around a little bit, do our thing, we're playing our game or whatever. And there we go, it saves again. Alright, so that's an autosave system. And if you want to save on leave, so let's up this to maybe like 60 seconds so it doesn't overload the data stores or anything. So now if we wanted to save on leave, saving on leave, then we're going to do game, so first we're going to do game, right, bind to close. Bind to close, function, self save, right? We're going to do game.players, or whoop, local players, game, service players, players.player, moving, connect, function, local connection equals nil, connection equals that. Player leaving. If player leaving is equal to self.player, then connection disconnect, and then we're going to do self save. Cool. So that should be an automatic save system. And then one problem is if since we're both binding to close and to player removing, then if the server shuts down, I think it would save 2 times instead of 1 time, but I mean, hey, it's just more saving. So now, if we ever load in the game, the character is invisible, I don't know why, but anyway, whatever, we're gonna ignore it. We leave the game, it should automatically save. Now it should also hold for a second, but it does save, right? Saves twice, like I was saying. But what this does, this actually holds the game. Like if the server's shutting down, it'll actually stop the server until it can save, right? And it'll have like 30 seconds to actually run the stuff before the server will finally shut down, right? And so that's like the perfect place to bind like a save function, right? So now we have like a perfect saving system. We have an autosave with saving on leave as well. And then we have a load system. We have all this stuff, and we can really do anything we want with this. We can go as far as you want. This is the entire stat system, right? We can add any stats that we want, and we can save them just by putting them in this table, right? We can specify which stats we want to save, which stats we don't, right? And it's as simple as that. It's pretty cool. And then you can do other things with this module script thing too. Like I have all kinds of module scripts for all kinds of different things. Like I have one for damage, right? I have different damage types. I can create a new damage object, and I can specify a damage type. Like I can do a raycast box, which is a type that was inspired by another module I saw using raycast hitboxes. And then I can do like magnitude sphere. I can do like dot touch. Well, I don't think I didn't include dot touch because dot touch is lame. But anyway, point is, module scripts are very, very useful for all kinds of things. You got to get creative with them, with what kind of objects you can create with them. You know. Anyway, yeah.